Okay, so if you remember in the last video, we were dealing with reference angles, and there were some, I guess, formulas, so to say, that tell you how to find the reference angle depending on what quadrant the angle theta itself is in. That is what quadrant the terminal side of the angle theta in standard position is in. But really, it's just better to draw the angle in standard position, and then you could visually see what the reference angle should be. Or at least visually how you should calculate it. It's just visualization. And also, we can also ask, well, what if theta is negative? That is, if it's less than 0 degrees or bigger than 360 degrees. And that's what I'm asking in these notes here. Or if it's in radians, what if theta is negative or greater than 2 pi? What you want to do is you basically want to calculate another angle. I denote it by this Greek letter alpha here. So you want to find an angle alpha that's coterminal with theta, such that alpha is between 0 degrees and 360 degrees. Or again, if you're dealing with radians, if alpha is between 0 and 2 pi, and then you find the reference angle for alpha. Because then by definition, the reference angle for alpha is the reference angle for theta. And how do you find that angle alpha? You basically have to add or subtract some multiple of 360 degrees, or 2 pi. You'll see some examples shortly if it's confusing what I'm saying. But let's do some examples to illustrate this. So as an example, I just moved this up. Let's find some reference angles. So here we have 115 degrees. Okay, well, let's draw that in standard position. So I'm drawing the XY plane. Here's X and here's Y. So again, in standard position, let me use green, right? Here's the initial side. Now, since it's 115 degrees, we know that this is 90 degrees. We know this is 180 degrees. And for fun, let me fill in the rest. 0 degrees, 270. So we know that 115 degrees, the terminal side, is somewhere in quadrant 2. So this is 115 degrees. Okay, so the reference angle then, remember, that's the angle that the terminal side of theta makes with the x-axis. So in this case, it's going to be the angle between the terminal side and the x-axis. And it has to be acute, so it has to be this angle. Okay, so how do we get that angle in red? Well, what we're going to do then is take the full, here, let me use this, 180 degrees, right? And we're going to throw this piece away. So we're going to take 180 degrees, and we're going to throw away 115 degrees. We're going to subtract. So we have 180 degrees minus 115 degrees. Doing so, we're going to get 65 degrees. And that's what the reference angle for 115 degrees is, 65 degrees. Okay, that's good. Let's now look at 210 degrees. Okay. There we go. So now again, we're drawing in standard position. Okay, so just like in the previous example, 180 degrees is here. This is 90 degrees. Here's 270. Okay, so let me use green again for fun. So 210, as you can see, it's going to be somewhere in quadrant 3. So it's going to look something like this. Okay, that's good. All right, so what would the reference angle be? Well, visually, it's going to look like this, right? Again, it's the angle the terminal side makes with the x-axis. But again, it has to be acute, meaning it's positive and less than 90 degrees. Or in radians, it's positive and less than pi over 2. So in this case, we're going to want to take 210, we're going to take 210 degrees and subtract off 180 degrees because we want this piece. So we have 210 degrees minus 180 degrees, and it looks like we get 30 degrees. So the reference angle for 210 degrees is 30 degrees. Okay, that's good. Let's do another one. Let's now look at 5 pi over 4. Now here, of course, we're in radians, as you can see, because there's no degree symbol. Now what you could do, if you want, is you can convert this into degrees. Okay, so for fun, let's do that. Might make it easier at this point. And how do you convert? Remember, you multiply by 180 degrees, divided by pi. Doing so, what do we get? Well, we're going to get 5 pi times 180 degrees all over 4 pi. Okay, so of course the pi's are going to cancel. So what we're left with is 5 times 180 degrees over 4. So of course we're going to need our calculator, which is good. So we get 900 degrees over 4. And that is going to be 225 degrees. Okay, good. So I got some room here. So the angle in degrees is 225. Okay, so that's good. Okay, now let's actually draw this in standard position, like so. Okay, so again, just like in the previous example, this angle is going to be in quadrant 3. So we're going to have something like this. And how do I know it's in quadrant 3? Well, again, this we know is 270 degrees. This is 180 degrees, so it has to be between the two. So just like in the previous example, the reference angle is this. And how do we get that? We're going to take our angle and subtract. In other words, we're going to take, see if I can draw this. Let me see if I can draw it here. 225 degrees minus 180 degrees. Doing so, we get 45 degrees. So that's what the reference angle here is, 45 degrees. So let me just fill it in actually. Yeah, this is good. So we have 45 degrees is our reference angle.